Okay, so today we're basically working backwards. Last week I would give you a function and I'd say, okay, find the zeros for me. So you would try factoring something out of the whole thing, factoring by grouping, synthetic division if we had to. Today is really the opposite. I'm giving you the answers and you're going to work backwards and give me the polynomial that it came from. Now, do you remember if I have, let's just make up a polynomial here. Let's say I had this. Y equals x to the third plus 2x squared minus 7. How many total answers will this thing have? 3. So the number of total complex answers, complex zeros we'll call it, is 3. Right? How many of these could be real? Yeah, all of them could be real, or only one of them. So 1 or 3. And why is it that way? Why is it only 1 or 3? Right. Remember that your imaginary roots always come in pairs. So when we did the number of imaginary roots, they have to come in pairs. So either they're going to come in a single pair, or I won't have any of them at all. So there's one scenario, 3 total answers, or here's the other scenario, 3 total answers. But since these have to come in pairs, those are the only 2 possibilities. I'm never going to have 2 real and only 1 imaginary. It doesn't work that way because they have to come in pairs. Not only do imaginary roots come in pairs, so do irrational roots. So we've kind of left irrational out of this whole scene so far, but now we're going to bring them back in. So, a big thing to note today, both imaginary and irrational roots come in pairs. So that's a big deal. They always come in pairs. Your rational roots do not necessarily come in pairs. They can be by themselves. They can have a friend with them. It doesn't really matter. Actually, we should extend this because let's say I have an irrational root, like I don't know, 1 plus the square root of 2. The partner that it comes with isn't some other random irrational root. It's its conjugate pair. Come in pairs called conjugate pairs. You already know that word from somewhere. Do you remember when we've talked about conjugate before? Yes.
When we were multiplying square roots.
Yes. Yes. So, recap back to this. If you had to rationalize this, for example, say you had, 7 over 2 minus root 3, and you had to rationalize that denominator, didn't you multiply by its conjugate? Right? Which was what? So for this one, it would be, it would be 2 plus root 3 on top and bottom. So that's what we mean by a conjugate pair. So it's the same pieces, but you would change the sign. So let's just list some conjugate pairs. So here's one example, 2 minus root 3 and 2 plus root 3. Let's do an imaginary one. What if you had 6 plus I? What would its conjugate pair be? 6 minus I. That's it. Now, sometimes your first number is 0. So what if you had something like, square root of 5? What would its pair be? What's the pair to this guy? Yeah, that's it. It's just negative square root of 5. That's it. So same thing if I had, like, I don't know, negative 2i. What would its pair be? Positive 2i. That's it. That's it. That's it. All you're doing is changing the sign. Okay. So now that we know that all irrational and imaginary roots come in pairs, here's what's tricky. If you look at this worksheet here, and let's just look at, I don't know, number 3, for example. Here's what they're going to do. They're going to give you the zeros, but they're never going to list the conjugate pair as a 0. That's up to you. So 3 is just a normal number. It doesn't come in a pair. It's just a normal rational number. I leave it alone. 5, normal rational number. Once I hit an imaginary or an irrational number, not only is negative 2i an answer, so is its pair, which is positive 2i. So I have to add it to the list. They're not going to do it for me. I have to add it. So that's really all they're asking you to do in 1 through 6. They want you to add whatever's missing. So let's do 4 together. This 0, the number 2, do I add a pair for it? No, because it's a normal rational number. If it's an integer, just a positive or negative number, it doesn't come with its partner. It's only these ones that are imaginary or irrational that always come with their conjugate pair. So, negative 1 minus I, what would the pair be for that? Negative 1 plus I. Well, yeah, that's one whole answer. Negative 1 minus I. So then negative 1 plus I comes along too. You follow me so far? Let's try an irrational one. How about 2? So, 1 plus the square root of 3 is an answer. So then what else must be an answer? 1 minus the square root of 3. And then if negative 3 plus the square root of 6 is an answer, so is? Yes, negative 3 minus root 6. So there would be all your answers all together. So there would actually be 4. You try it for number 1. Okay. Does 2 come with a partner? No, you leave it alone. If 2 plus 3i is an answer, then so is 2 minus 3i. If 1 minus I is an answer, then so is 1 plus I. Does that make sense? That's all you have to do for these. They're just asking for what other zeros are there that aren't listed. Yep.
Wait, so why do you need, like, just constants alone?
Because they can come by themselves. They don't have to come in a pair. Right. They're the only ones that can come by themselves. But imaginary and irrational have to come in pairs. Okay, real quick, try 5. Does 1 come with a pair? No. Negative 1 plus 2 root 2. Does it come with a pair? Yes. Who's the pair? Negative 1 minus 2 root 2. Okay. Are we all rightish with this? Alright. Do 6 just for good measure. And then we'll switch gears. Okay. 1 minus 3i will bring who else to the party? 1 plus 3i. And negative 3 minus 2i will bring... That's it. Notice that the sign of the first number never changes. Right? It's only the sign in the middle that you have to change. Alright, so we have that down. Okay. Now what I want to do, before we look at the next part, I just want to recap what we've been doing. Okay, so I've given you a polynomial like this, and I say, okay, find me the zeros of this thing. So first thing you do is you look if I can factor something out of the whole thing. I can't here. So then what might you try? Yes, so I have 4 terms I'm going to try and factor by grouping. Looks like I can here. I could take out x squared, right, and get 2x minus 3. I could take out, oh shoot. Oh man.
You can do it.
I think I actually messed up.
Wait,
This is supposed to be a plus. Sorry.
practice problem?
Yeah, I just made this up. But I meant for that to be a plus. Sorry. So now, okay, we can factor out negative 1 and get 2x minus 3. Okay, parentheses match. So I have x squared minus 1, 2x minus 3. Then what can I do?
Can't you factor out the x squared one?
Yeah, that one's going to split into x plus 1, x minus 1. And I have 2x minus 3. So if I'm trying to find the zeros of this, right, don't I have them now? Right? So my zeros would be negative 1, positive 1. And then what would come from this one? Positive 3/2, right? Right? Everybody's okay? We're literally going to go backwards now. I'm giving you these. And then from each one of these zeros came from a factor, right? Right? Do you see that? He came from that, he came from that. So if I look at, gosh. Let's try number 8 together on our worksheet here. First of all, when I'm looking at 8, I'm going to ask myself, are there any zeros that should be in this list that aren't, that they didn't tell me about? No, this doesn't have any irrationals or any imaginaries. So step 1, if you're going to write the equation that it came from, fill in any other zeros that they didn't give me. Well, lucky for us, they're all there. Okay? So then I need to ask myself, this negative 1, what factor did it actually come from? Well, so here's one. A negative 1 came from x plus 1, right? Because when you solve it, you get out a negative 1, right? So if I'm working backwards, if I got negative 1, that means the factor that it came from was x plus 1. Does everybody agree? So then where would a negative 3 have come from? X plus 3.
I didn't know that it wasn't like 6 and it's like a 2x plus.
Great question. So, see right here, if you read the directions, it says write a polynomial function of least degree. Oh, with a degree. You don't not know that. You're giving me a polynomial that has these three answers, not the only one. Because that would give you another one. Yeah. So we're just going to take the most basic one, and that'll be one polynomial that has these zeros, but not every single one. Does that make sense? Okay, perfect. So I have this. Now, where would 2/5 have come from?
5x minus 2.
Yeah, that would be a 5x minus 2, right? Because you would add 2 divided by 5. So that can be a little tricky. So just make sure when they're fractions, your denominator would come out in front and your numerator would come over to the side. So, what'd you say?
Just like calculator.
Yeah, well, you're doing the opposite. You're going to just multiply them together. Right? So if I'm working backwards, so now I went from this line to this line, and now I need to go back up. So I would FOIL 2 of them together, get an answer, and then once I have that answer, I'd FOIL it with the last thing, and I'd get all the way back up. So this part is not particularly hard, it's just kind of tedious sometimes. So I would FOIL the first 2 together. And then I just need to multiply it by the 5x minus 2.
That's all you do.
That's it? They just get nastier when you have funky imaginary and irrational roots. But that's the idea. So once you have given your zeros, step 1 would be to add any other zeros that aren't in that list. So any irrational or imaginary pairs that aren't there, you got to put them. Then you just figure out the factor that they came from and multiply all those factors together. A quick thing to do to check, however many zeros you have should be the same as the number of answers. 1, 2, 3 should be the same as the degree of your answer. Yeah, so that's a real quick thing to check. I have 3 zeros, I'm of degree 3, so at least I'm in the right ballpark. You could always work backwards if you really wanted to check, right? Now I can take my equation and see if I can work my way back and see. Or you can just take these numbers and plug them in and see if they work. Bless you. Bless you. So let's look at 9, for example. First, do I need to add any zeros that aren't in this list? No, lucky us. Where would 2/5 have come from? 5x minus 2. Oh, it's the same one. Where would 1 have come from? X minus 1, and negative 3 would come from x plus 3. Is everybody okay with that so far? You see why they are what they are? And now just multiply them all together. How did we do? Is everybody all right? Did you match what I got? Are we ready to step it up a notch, or should I let you try one all by yourself? Okay, I'll let you try one all by yourself. How about how about 17? That looks like a good one. Anybody think they have the right answer? Maddie, go ahead.
4x to the third minus the 9x squared minus 49x minus 30.
Looks good to me. All right, are we ready to step it up a notch? Before we go too crazy, just look at number 20. What does that even mean? Negative 1/4 mult 3. Cody? Right. So it just means that you have negative 1/4 3 times. So that means, first of all, are any of these bringing anybody to the party? Do they have to bring a conjugate pair? No, they're all fine. What factor does negative 1/4 come from?
4 plus 1. 4x plus 1.
Yeah, 4x plus 1. So when you have a multiplicity of 3 like you do in this case, it just means that there's 3 of them. That's it. So you would just have 4x plus 1 3 times. And multiply it all together. Whatever that ends up being. Okay? So with the multiplicities, you would just have that factor that many times. Alright, let's get to some imaginary irrational stuff. So, zoom all the way back up to 11. Here's one where finally we got to bring someone else to the party. Who's coming? 2 minus root 5 is also a 0. That was not originally listed, so I have to add it. Okay, so that means that my final answer should be degree what? 3, because there's 3 total zeros. Okay, now, here's where things get a little confusing, but it's the same idea. I think I'm going to need more space. This 2 right here, what factor does it come from? X minus 2, right? So all I have to do to get the factor is to do x minus whatever that number is, right? So if it was a negative number, it would turn into a plus, right? Right. I'm going to do the same thing with these. It's just that it's more confusing. So to turn this thing into a factor, I have to do x minus all of this. So it's going to be minus 2 minus root 5. And then this thing is going to turn into x minus 2 plus root 5. Do you see that? You have to subtract the whole thing. So I have to minus both of those, but in this case that turns that one positive. Okay. Now, are you ready for this? Yes, you are. You all were born ready for this part. Here's what you're going to do, Tantasquins. You are just going to multiply all these together, but you're going to work smarter, not harder. You're going to multiply these two with each other first. What's going to happen is that all the irrational parts are going to disappear. It'll be so nice. So let's ignore the x minus 2 for that first factor. Let's just ignore it for a minute. Multiply these two together. Okay, I know it's a 3 by 3, but what are you going to do? So take a moment and we'll multiply these two together. You might need more space, sorry. Bless you. Now this part right here is so satisfying. This is what makes it so fun. Bless you. If you've done everything right, all the weird stuff is going to cancel. All those irrational things will cancel out. Wait till we do an imaginary example. That's real fun. So, watch this. I have a negative x root 5. But lo and behold, I have a positive x root 5. They cancel with each other. By golly, I have a positive 2 root 5 and a negative 2 root 5. They cancel with each other. Everything else is just a normal number, so I'll just put those together. I'd get x squared minus 4x. Looks like minus 1. So when I multiply these two together, I got that. I do still need to multiply by the x minus 2. So but now, look, I'm down, there's no irrational numbers anymore, so it's much easier. So now I'll just multiply that through, and I'll have my answer. Wasn't that satisfying? We went from these crazy, irrational zeros, and look at what a nice, neat polynomial we came up with. So, things that you want to be checking for. Everything should cancel out, because if you read the directions, it says, write a polynomial of least degree with integer coefficients. So when you finish, all of these need to be integers. There should not be any irrational or imaginary numbers left when you get this. Okay, they should all look like a nice clean polynomial. Does that make sense? So it just takes a little bit of practice to get used to this minus the whole thing business. And yes, it's sometimes tedious to multiply 3 by 3s. What can you do? All right, so we will practice some more after lunch.